So the first thing I want you to do, this is not on your paper, this exercise, I want you to consider how you would label on the number line the solution to this inequality. Okay, so pause the video, draw yourself a number line, and label it with solutions. You know, would -7 be a solution? Right, I mean less than 5, -7's less than 5. Would that work? Okay, so pause the video and try that. Now, if you're back, I hope you realize there'd be an open circle at 5 because x can't equal 5. All of these values are fine. Same thing with these negative values, except I can't have the absolute value of -5, right? And I couldn't plug in and have the absolute value of -6 or anything less than that. Okay, so this is the solution to that inequality. And I hope you remember doing this at some point in high school where you said the solution to this is actually that. Okay, so whenever it was absolute value, you made this compound inequality. Compound means there's two symbols. You made this compound inequality between the positive and negative value. Okay, so that being said, let's take a look at number 1 here. So following what we just said, we create a compound inequality, and then we just solve for x. Okay, so this would be in between +4 and -4. Okay, we would solve for x by adding 3 to both sides, or all 3 sides actually, and I'm left with this. Okay, so start letter C. So you get it started. And then something else interesting happens in letter C that I wanted to remind you of. First, we would subtract 3 from all 3 sides. Right? I hope you're good with the -5 minus 3. All right, that would be -8. And then we need to divide all 3 sides by -2. Okay, and so the people doing this lesson in class, I asked the class who remembers what happens when you divide by a negative when you're working with inequalities, and usually someone remembers that it means you flip the inequality symbol. And for the sake of time, I'm going to offer that up without any more explanation. I could show you that, you know, if you had -x less than 7 and you divide both sides by -1, right, we couldn't say then the solution is x is less than -7. The solution would have to become x is greater than -7. And you can play around with that and verify that that's true. And I said I wasn't going to give you an explanation, but I just gave you a little one, so I can't help myself. I don't like to offer up rules without any justification behind them. So anyway, we get to here, and then this just looks awkward, right? This says 4 is greater than x is greater than -1. We want it to look more like the answer in number 1, right? Where we have the lower value on the left. So that's an easy thing to change. Let's just change it so that the negative is on the left, and then we are looking at this. All right, so you try letter B. Pause the video, try letter B. .01, sorry, that's all scrunched up. Final answer would be 1.99 is less than x is less than 2.01. Didn't give myself enough room to work. Okay, final answer. Okay, so let's go down and look at some of these exercises below. Let's actually start with B. And before we get started, let me tell you about a time that I took my son to the doctor, and he had a condition on his face, his skin, and the doctor said to me, well, you know, if we don't do anything, right? If we just left it alone, it's going to do one of three things. It's either going to get better, stay the same, or get worse. Okay? And I was like, gee, thanks, doctor. That was so helpful. Okay? But anyway, when we're working with a function, okay, and actually this, I'm drawing the picture from your quiz because a lot of you had trouble with this problem on the quiz about where the function is positive and negative. Any given function, right, is either greater than 0, or it's 0, or it's less than 0, right? That's kind of like what the doctor said. There's only 3 possibilities that we have to consider, okay? It's either greater than 0, 0, or less than 0, okay? This function is 0 right here at positive 2 and negative 2. Remember, where is this function positive? Where is this function greater than 0? Remember, y values. If I say where is the function, then I'm talking about the values of y, right? Functional values are y values. So this function is positive from negative 2 to 2. This function is negative, and this is what you should have written on your quiz that a lot of you missed. This function is negative from negative infinity to negative 2 union 2 to infinity. Okay, so we're going to be taking a look at functions today and determining where they're positive or negative. And we're going to start then by determining where they're 0, right? Because in between the zeros, my function's either completely positive or completely negative, right? Because otherwise I'd have another 0. Okay, so I'm completely above the x-axis, right, between this 0 and this 0. So going back to this example, and what I like about these examples right before midterm week is you get some review on factoring. Okay, so I'm going to have you pause the video and factor this. Let me just remind you a little bit. You know, you could, the AC method would be nice here, right? The AC method. Get 12. This is kind of nice because all the signs are positive, so you know you're only going to have positives. But if you like to do the guess and check, like you could have 2x and 2x, or you would have like 4x and 1x, right? But then factors of 3, do you put the 1 and the 3 here, or does the 3 go here? Right? Would the 3 go here and the 1 go here? So either do this by guess and check or do this by the AC method, right? Which is pretty easy to see factors of 12 that give me 8. Okay, so pause the video and get this factored. Okay, so by the AC method, I am getting the factors 2x plus 3, and then 2x plus 1. And first I want to find where this function equals 0. Okay, then I'm going to worry about what the problem actually says is where is this greater than 0? Where is this function positive? All right, so you probably, some of you could probably do this in your head, but you probably need to set each factor equal to 0. All right, and then solve. Okay, so you should get negative 3/2 and negative 1/2. Okay, so I'm going to make a big long number line here. Here's negative 3/2. So this is where my function is 0. So in between the two zeros, my function is either going to be positive or negative. Okay, so what I do is I pick any value. So this is negative 1/2. I pick any value in between here, like say 1, right? Or negative 1. Negative 1 would fall between negative 1/2 and negative 1/2. And then I'm going to see if the function is positive or negative. So what I do is I come up here in factored form, where my function's in factored form, and I plug in negative 1. All right, I don't care what I actually get as a numeric answer. I just care whether it's positive or negative. Okay, so if I plug in negative 1 right here, negative 2 plus 3, that would be positive. So I'm just going to write positive here to show that my first factor is positive. And over here, if I plug in negative 1, I'm going to get a negative, right? Because I'd have negative 2 plus 1. All right, that means that my function, right, positive times negative is going to be negative. So that's telling me my function is negative between negative 3/2 and x equals negative 1/2. Okay, so what's happening when x is greater than negative 1/2? It's got to either be all positive or all negative, right? Because otherwise I'd come back up to 0 if I were to change between positive and negative, right? And I know these are the only zeros of my function. So I'm either all positive or all negative when x is greater than negative 1/2. So I pick just any value greater than negative 1/2. 0 is a wonderful test value because it's so easy to plug in 0. But I could test 0, I could test 1, I could test 10, right? Whatever I want. All right, that's greater than negative 1/2. Okay. If I plug in 0, right, that's 0, positive 3. That's 0, positive 1. So both factors are positive when I plug in 0, which means then my function, right, positive times a positive is positive. All right, so my function is positive from negative 1/2 all the way to infinity. Come over here, let's see, what's less than negative 3/2? How about negative 2? All right, but again, I could test negative 2, negative 3, negative 4, negative 100, right, whatever I want. Okay, so you try this. Plug in negative 2. I don't care what the numeric answer is. I just care whether you get a positive or a negative. Okay, so I hope you noticed this was negative, but on this side, oh no, wait, on this side, we also get a negative, all right, which is positive. All right, so then I would write my final answer. Where is my function positive? Make sure you recognize that these values, never put your test points into your intervals. These values are what create the endpoints of the interval. So I would write my answer like this. This function is positive from negative infinity to negative 3/2 union negative 1/2 to infinity. Okay, so let's do one more together, and then I'm going to turn you loose to try some on your own. So let's go back and try, wait, where is it here? This one, letter D. Okay, and the good news on letter D is it's already factored. You don't have to do any factoring, so we can jump right into the point where I list the zeros on a number line. Okay, so where is this function 0? And one of the values is at 1, okay, because 0 squared is still 0, right? So it doesn't matter that that's squared. And the other value of x that makes this 0 is negative 3. Okay, now I pick test points in between here. I love testing 0. It's so easy to test, right? So easy to plug in 0. 0 is between these two, so I'm going to test 0. Then anything bigger than 1, so how about 2? And anything less than negative 3, so how about negative 4? Okay, so these are the values that I'm going to test. And look at this part. When I square something, right, squaring something always makes it positive. right? So I know my first factor is always going to be positive because it's squared. Okay, so really, I just have to see what's going on when I plug each of these test values into the part x plus 3. Okay, so you try that. Plug each of the values I have here in green and decide whether you get a positive or negative. Okay, so that would be negative, positive, positive. So I'm being asked, where is this function greater than 0? I am greater than 0 from -3 to 1. Notice it's always the zeros that form my endpoints, right? Sometimes students put their test values into their intervals. You never want to do that, okay? Because the zeros of the function are where the function changes from positive versus negative, okay? And that would be my final answer, okay? So I'm going to turn you loose and have you try you're going to try A and C, and then in the next segment, I'm going to show the answers. Let me just talk about something on letter C, though, for a minute. A lot of you would probably, because we know that, you know, setting things equal to 0, you've got to bring all your terms to one side. A lot of you would probably bring the -7 to the left, right? That way you only have to move one term, all right? But I would move the -2x squared over to the right. Okay, and then also bring the 13x over to the right. Now, why would I do that? Right? Why would I move 2 terms instead of 1 term? Okay, and the answer to that is I always want my leading coefficient to be positive, right? Because this is going to be some challenging factoring. You guys can do it though. Right, so if I bring both of these to the left, then I get this expression, then I have to factor. But I never want to factor if I have a negative leading coefficient. That just makes everything harder. All right, so you work on A and C and then check your answers in the next video.